Hello, it's Mrs. Geoscience here and welcome to my video on power. I'm trying something a little bit different. I'm using blue giant post-it notes, so do give me feedback on what you think of this in terms of being able to see what we're talking about. So today we're going to learn about power, we're going to define it, we're going to learn the equation and the symbols for it, we're going to look at the units as well. And we're also going to look at rearranging the equation. And then finally, I'm going to take you through some example questions using the equation and rearranging the equation. So first thing we've got to do is define power. So power is the rate of energy transfer. Okay, so the definition of power is the rate of energy transfer. Rate of energy transfer, or you could otherwise call it the amount of energy divided by time, or energy transferred over time. It's also the rate of work done, okay, because work done equals energy transferred. And the equation for power is power equals energy transferred divided by time. The unit for power is the watt, and the unit for time in this equation is seconds, and energy is of course joules. If we wanted to change our equation to be a symbol equation, we would use the symbols capital P for power, capital E for energy, and a small letter t for time. Okay. What's really important, I've just spent a lot of time marking my Year 11's mocks, and you need to be really clear on what you're putting in the equation. My advice would always be, when you're asked to recall equation, write it out in words. That way you can't really have much confusion. But if you are going to write it out in symbols, make sure it is the symbols for the quantities that you're writing out and not the symbols for the units. Okay, so to be clear, this is power equals energy transferred over time. The units for power is the watt, and the symbol for a watt is a capital W. The unit for energy is a joule, and the symbol for joule is a capital J. And the unit for time is seconds, of which the symbol is a small s. So that is the correct symbol equation for this. I have seen people write things like watts equals energy divided by seconds, and that is incorrect. Okay, you would not get the mark for that. Finally, we need to look at rearranging this equation. So there are two routes to rearranging equations in physics. For simple equations like this one, I would recommend a formula triangle. Okay, so we draw out our triangle, and the quantity that's at the top of the dividing line goes at the top of our triangle. In this case it's energy, and then the other two go at the bottom, so power and time. And we've already got the arrangement for power, so to rearrange for energy we would cover up energy, and that is energy equals power times time. And then to rearrange for time we cover up time, and then we get time equals energy divided by power, because energy is at the top and power is at the bottom. When you're choosing what to put in your formula triangle, note that the quantity that is at the top will always be at the top, no matter how you're rearranging the equation. Okay, the other way to rearrange the equation is mathematically, and I will do that as we go through the sample questions. So key points from this one: remember, power is the rate of energy transfer, the equation is power equals energy transferred divided by time, and the unit for power is the watt. Okay, so the first question then says, what is the power of a light bulb that transfers 60 joules of energy per second? So to work this out, we need to first recall our equation. So the equation is power equals energy transferred divided by time. and we need to figure out what quantities we already have. So we've got 60 joules, so energy equals 60 joules. And we don't actually have a specified time, but it's saying 60 joules is transferred per second, so we could just do it for 1 second. So time equals 1 second. So we then substitute the numbers we know into our equation. So power equals 60 divided by 1. And then obviously you don't need a calculator for this, but 60 divided by 1, of course, equals 60. So then that gives us the answer, power equals 60 watts. Okay, there's no need to do any more to this. That is a perfect answer. Okay, so power equals 60 watts. Okay, question 2. Let's move on to question 2. So question 2 states, how much energy, so we're working out energy, how much energy does a 700 watt microwave transfer when on for 2 minutes? First thing I am already picking up before I've done any calculations is that my time is in the wrong unit, it's in minutes. So first thing I need to do before anything else is convert that into seconds. So there are 60 seconds in a minute. So to get seconds, we're going to have 2 multiplied by the 60 to give us 120 seconds. First thing I would do, just then I know I'm clear before I've tried the difficult task of rearranging the equation. So I told you we were going to rearrange it mathematically, but I've got my formula triangle here just to confirm energy equals power times time. But let me show you how you would rearrange it mathematically. So we're starting out with the equation we know, which is power equals energy transferred divided by time. And we've got our power rating is 700 watts, so we're going to put that number in the power area. We don't yet know the energy, that's what we've got to work out. And the time we worked out already is 120 seconds. Okay, so now I need to isolate that energy transferred to get it on its own. Okay, so in order to do that, I need to make it so that that gets onto that side of the equation. Okay, so because it's at the bottom of a dividing line, if I multiply both sides by that amount, I will get the missing value. So if I multiply both sides of the equation by 120, so I get 700 times 120 equals my energy transferred. I'm then going to get the value I need. Okay, and just to check that I got the rearrangement correct, I'm just going to go back here where I told you already that energy equals power times time. Yeah, I'll just put that over the top. And so we're going to do that on the calculator. You do get a calculator in your science exams. So 700 times 120 to give me 84,000 joules. Okay, so energy transferred equals 84,000 joules. Okay, sorry, the light's not great there. Okay, so 84,000 joules. Right, question 3 then. How long does it take a 400 watt toaster to transfer 72,000 joules of thermal energy? And we're going to assume 100% efficiency here. I was going to come up with a question using efficiency, but I thought no, we better stick to the equation we know. Okay, so first things first, do I need to adjust any of my units? No. Power's in watts, energy transferred is in joules, there's no kilos or megas or anything like that, so nothing needs to change here. So again, we start with the basic equation. Power equals energy transferred divided by time. So I'm just going to use the symbols now for speed. Okay, so power, our 400 watts, equals our 72,000 divided by time. Okay, and now I'm going to have to multiply both sides by time and divide both sides by 400 to get me to the right place. I would do it step by step just for just so that I don't make any mistakes. Okay, so first step is times time, so 400 times time equals 72,000, and then divide by 400, get time equals 72,000 divided by 400, and that gives you an answer. Let's do it on the calculator. So 72,000 divided by 400 to give you 180 seconds. 180 seconds. Okay, that is an answer. Okay, you don't actually need to change that unless the question had said turn it into minutes. Okay, so just to turn it into minutes, we're going to divide by 60, and that gives us 3 minutes. Okay. Don't do more calculations than you need to in your exam. It's a waste of time and potentially causes you to make mistakes. All right, finally, this question, question 4. 2 motors lift a 50 kilogram mass 5 meters. Motor A takes 2 minutes, motor B takes 4 minutes. What is the difference in power of the 2 motors? Now, the reason I put this question in is as I was looking at your specification to determine what to put in this video, it specifically referenced an example of you being able to compare the power of two devices, for example, 2 motors lifting a mass. So I thought that's a really likely exam question to come up. Okay, so this is the sort of question that's going to be a 5-mark question, or possibly 6 marks. It requires 2 steps of calculations. Okay, so the first thing is the only quantities you've been given are mass, a height, and some time. But power is energy transferred divided by time. So we don't have enough to use that power equation yet. Okay, so we've got that in mind, but what we do have is we have mass, we have height, we have power. We actually have enough to work out the energy transferred, okay, because we know that the gravitational field strength on Earth is 10. So we do have enough to work out energy. So that's the first thing we're going to do. So GPE or EP equals mgh. So energy transferred equals mass, which is 50 kilograms, multiplied by the gravitational field strength, which is 10, multiplied by the height in meters, which is 5, and that is going to give us 2,500 joules. You can check that on the calculator if you need to. I'm interested in your practice for the power equation. So now we've got the energy transferred, we've got the time, we need to work out the power of each. So I would actually just split my page in 2 and say motor A and motor B. Okay, so power equals energy over time equals 2,500 divided by, oh wait, I've got a time in minutes, so I'm going to have to turn that into seconds. So that's 2 times 60. And then motor B, I'm going to do this same stage next to it. Power equals energy time divided by time, 2,500, because it's the same amount of gravitational potential energy gain no matter how long it took, isn't it? And then the time is a bit longer because it's 4 minutes, so 4 times 60. So to work that out then, we're going to have 2,500 divided by 120, which gives you 20.8 watts. And then we're going to have 2,500 divided by 240, which gives 10.41 watts. Okay, this would be enough to get you most of the marks, but the question asks what is the difference in power. So that last step, you can just put power difference, and there'd probably be a space on your paper that just where you're expected to write the answer, but power difference is 20.8 minus 10.41, and that's going to give you an answer of 10.38 watts. Okay, I hope you found this video useful. It's given you, as I will remind you, the definition of power, the equation for power, the symbols for power, the units, how to rearrange the equation, and 4 example questions. So if after watching this video you're still unsure about the concept of power, please write in the comments below. Make sure you subscribe to my channel so that you can see when new videos are published. I plan to get everything in paper 1 published by the Easter holidays, so I've got quite a lot coming up for you, and if you have any other questions, please write in the comments below. Bye!